Mole concept, AR and MR. Hello class. Before we begin, please ensure that you have these relevant materials. You'll need your notes, chapter 8a, the mole. You need a calculator and the periodic table. You may use the periodic table at the back of the notes or your 10-year series. Sounds good? Alright, before we begin, when we go through the slides, the top will always show the page number and subtopic. If you see any underlined words, you need to fill them in your notes. If you see any highlighted words, you may choose to highlight them in your notes. And finally, if you see any scribbles or red words, you need to add them on to your notes. Alright, let's begin. Class, have you ever wondered about certain definitions? Like how you define 1 meter and how do you define 1 second? Okay. How did everyone decided that this certain length is 1 meter? Like everyone in the whole world decided that this certain length is 1 meter, or everyone decided that this short amount of time is considered 1 second. Have you ever wondered how we came to define such units? Think about it. Okay. To define such units, we need to have a certain frame of reference. Okay, we need to measure it against a certain standard. Okay, last time, okay, when we decided to define the meter, okay, we had this meter bar kept in a laboratory. Okay, it's made of platinum and iridium. Okay, and the scientists decided that this is 1 meter. So if you want to find out what is 1 meter, you have to go to this lab, you need to borrow this meter bar and then check that you had the definition of 1 meter correct. So as you can already imagine, okay, it is quite a difficult process to determine that whether what you have is 1 meter. And also, this is a physical object. So when example, okay, it is a warmer day, this meter bar will expand slightly. So does that mean that we now suddenly have to redefine all our 1 meters? Yeah, so as you can see that scientists decided that this is not a very reliable way of defining 1 meter. So they needed to find something that is constant, a standard that does not change. And then we discovered that the speed of light is constant, it does not change. Then after some debate, okay, we then define the meter as the length of the path traveled by light in a vacuum in 1 over about 300 million of a second. Okay, so when we define certain units, okay, we always try to define it against a reference that does not change. So how does this relate to what we are going to learn today? Okay, if you turn to page 1 under relative atomic mass, okay, we were going to define what is relative atomic mass. Okay, the relative atomic mass or AR of an element is the average mass of one atom of that element compared to 1/12 of the mass of one carbon-12 atom. Okay, this definition you would need to memorize. Okay, so here the standard that we are measuring against is 1/12 of the mass of one carbon atom. Alright, it is quite easy to get because carbon is quite abundant. And something to note, okay, why is it called relative? It's because we are comparing it to 1/12 of the mass of one carbon-12 atom. So what does this all mean? Okay, the definition seems very long and complicated. So let me explain through an example. For example, the average mass of one oxygen atom is 16 times as heavy as 1/12 of the mass of one carbon-12 atom. So this is the reference point, 1/12 of the mass of one carbon-12 atom. Oxygen is 16 times as heavy as that. Therefore, the relative atomic mass of oxygen is 16. Okay, if that still doesn't make you understand, it's okay. Right, you just need to memorize the definition. But the main concept is from the periodic table. Okay, if you look at the key, the relative atomic mass is the bigger number, which you can find at the bottom of each chemical symbol. Turning to page 2, relative molecular mass. Okay, so the definition is very similar to the relative atomic mass. Okay, the relative molecular or formula mass of a compound is the average mass of one molecule of that element or compound compared to 1/12 of the mass of one carbon-12 atom. Once again, you just need to memorize this. Okay, take note, when we refer to relative molecular mass, we are usually referring to covalent molecules. And if we say relative formula mass, is for ionic compound. Okay, to make it simple, okay, we usually just say everything to be relative molecular mass or MR. Alright, so previous lesson I've introduced you to how to calculate molecular mass. And MR is calculated by adding the relative atomic mass of all the atoms in the chemical formula. And please remember, AR and MR has no units. So example, find the MR of C2H5OH. Okay, we have 2 carbons, so it's 12 times 2, followed by 5 hydrogens, 1 times 5, plus 1 oxygen and 1 hydrogen. Okay, if you still cannot see, you can write notes there. So this is the C2H5OH. And if you use your calculator, you'll get the answer to be 46. I remind you again, there is no units. Next example, find the MR of Cu bracket NO3 2. Okay, so when there's brackets, what do we do? Okay, same thing. Alright, we will use the formula to help us. So copper is 64 plus bracket 14 plus 16 times 3. Okay, that refers to the NO3, and since there's 2 of them, I multiply by 2. Okay, once again, copper is 64 plus NO3 times 2. Okay, please take note that before the bracket is a plus. Okay, we are adding 2 of NO3 with copper. And if you use a calculator, you will get 188. And the last example that we went through was Na2SO4.7H2O. Okay, and if I have explained before, okay, this is a hydrated salt. Okay, that means there's a salt structure, in this case Na2SO4, but is attached to 7H2O. So when we are calculating the MR, we are calculating the whole thing. Okay, the salt with all the water attached. Okay, this whole structure actually makes another crystal structure. Okay, so we need to calculate the entire thing. So similar, Na2 plus SO4 and 7H2O. So is added. So the dot there is just to separate the water from the original crystal. And since there's 7 of them, I need to use 7 bracket 1 times 2 for H2 plus 16 for oxygen. And you just put them in inside the calculator and you get 268. Alright, now turn to page 3. We shall now discuss about percentage composition. Okay, to calculate the percentage of an element in a compound, we will use this formula. Total AR of the element over the MR of the compound times 100%. Okay, please write this down in your notes. Okay, you can pause the video to do so. Okay, the best way to explain what this concept is by giving an example. So if you look at example 1, find the percentage composition of copper in copper 2 sulfate, CuSO4. Okay, I want you to imagine that we have a copper sulfate molecule of sorts. Okay, so what this question is asking, part of it is copper. We want to find out what is the percentage of copper in the entire copper sulfate. So with that, we always need to find the entire thing first, which is the MR. So when we calculate the MR of CuSO4, okay, we get 160. And to find the percentage of copper in CuSO4, okay, we take the total AR of copper in CuSO4 over the entire thing, which is the MR of CuSO4 times 100%. So we have 64 out of the entire thing, 160 times 100%. Okay, since there's only one copper atom in CuSO4, okay, it's just 64 out of 160 times 100%. And we will get 40%. Okay, pause the video here, okay, to write down the workings. Next, let's look at example 2. Find the percentage composition of hydrogen in ethanoic acid. The formula given is CH3COOH. So once again, we need to find what is the percentage of hydrogen in this entire thing of CH3COOH. So calculating the MR of the entire thing first. Okay, we have 12 plus 1 times 3 plus 12 plus 16 plus 16 plus 1. Okay, and that is 60. Okay, so percentage of hydrogen in CH3COOH is the total AR of hydrogen over the MR of CH3COOH times 100%. Okay, look at the formula. How many hydrogens are there? Okay, yes, there is 4 hydrogens. So since the AR of hydrogen is 1 and there's a total of 4, so the percentage of hydrogen in CH3COOH is 1 times 4 out of the entire thing, 60 times 100%. So take note again, it's times 4 because there are 4 hydrogen atoms in the entire thing. Calculating that, you'll get 6.67%. Pause here to copy down the workings. Example 3. Hydrated copper 2 sulfate crystals, CuSO4.5H2O, can be dehydrated by heating. Calculate the percentage by mass of water present in the molecule. So this is similar. We are just finding out of this entire hydrated copper 2 sulfate crystals, what is the percentage of water inside. So once again, the entire thing, the MR, if you calculate it out, it is 250. So the percentage of water in CuSO4.5H2O is 5 of water. So it's 5 bracket 1 times 2 plus 16 for H2O over the entire thing times 100%. And you will get 36%. Okay, I'll give you some time to understand what is the working. Okay, if you have finished writing all the workings for the 3 examples, okay, try checkpoint 4 on your own. Okay, we'll come back and we'll discuss the next topic.